Now that we've visualized where we want to do our physics checking, it's time to do the actual code for physics checking. And again, this might seem complicated. It's going to seem simple by the end of this course. Let's open up our player script one more time. And we're going to go down to our update method. In our update method, we want to check to see if the player is touching the ground or if they're not touching the ground. And we want to do that by using this little laser that we've drawn in the gizmos. But unfortunately, the gizmos are just a debugging visualization. They don't actually give us any information back, and the gizmo code can't check to see if we're touching the ground or anything. It just gives us an idea of what we're looking at, and as long as it matches up with our physics code, then it'll tell us kind of what's going on with our physics code. So what we're going to do is use the Raycast2D raycasting system. And if you want to take a look at the documentation for it, the Unity page has pretty big documentation that goes over a lot of the different parameters that are available and has some example stuff, but I feel like the example's a little bit more complicated than what we need right now. Let's go back to our code now, and before we make the physics code, let's do one little change to our gizmos code. Right here on line 15, we calculate our origin by using our position and then this bottom y variable. The bottom y variable is assigned right above on line 14, which is actually just the extents.y. Let's replace bottom y here with just extents.y so we can get rid of this variable. And I'll explain why we're doing this in just a moment. But first we'll copy. So I'll select this whole sprite renderer.bounds.extents.y, hit Control or Command C, or right click and hit copy. And then go to bottom Y over here, just double click on it and Control V or Command V to paste over it. I'll zoom out with the mouse wheel here. So it's Control and the mouse wheel to remember this little slider down here. So I guess it's like a drop down. Go to 100% or whatever. Zoom back in a little bit. But now we've got this origin calculated without this extra line here on 14. I'm going to go to line 14, anywhere on it, hold Shift and hit Delete. And then I'll explain why we did that. We're actually going to reuse this origin right here down below in our update. And if we have two lines of code that we have to copy, then we have two lines of code that we need to update and double the chance of making mistakes. If we cut it down to a single line here that does everything we need and we don't need that extra variable, which really wasn't very useful for us, then this will just kind of work. So now we're going to take line 14 and we're going to copy it. We're going to hit Control C. And then we'll go down to line 21, hit enter, enter. I'm going to go up. I just wanted a little bit of space there, and then hit Control V. We're going to get an error here. Take a look at it and see if you can spot the error. You should be able to tell by the little underlined squiggly that there's a problem here. It's saying, hey, this sprite renderer does not exist in the current context. And why is that? Well, if we look at it, up here on line 13, we're finding the sprite renderer, but that's inside of our onDrawGizmos method. Down here on line 22, we're inside of the update method. Since this variable is defined inside of a method, it's not a member variable. It's not available to everything in the class, only to this method. So our update method can't see the sprite renderer. Now our jump duration and jump velocity, jump end time, these variables are all defined outside of the scope of a method. So they're all accessible outside of there. So what we could do is make it so that our sprite renderer is available outside of this scope. There are a couple issues with that, specifically with how onDrawGizmos works, or we could alternatively just get the sprite renderer down and update. And that's where we're going to start, and we'll talk about caching and some performance benefits of other ways we can do it a little bit later on. So let's take line 13, select the entire line, copy it with Control or Command C, go up above line 22, right here on 21, after the brace, enter, get a new line, and Control V to paste. The error should go away, and now we have an origin. We haven't done anything with it yet, but we've got the origin in our update method. Let's add a new line. So I'll click at the end of line 23, add one more line, and in here, let's do our raycast. We're going to say var hit equals, and this is where we're going to tie into the physics system, physics, P-H-Y-S-I-C-S, 2D, got to get that 2D part in there, dot raycast. Then we'll do an open parentheses, And the first variable that we need to give it is the origin. So that's where we're going to start. And notice that I name my variables to kind of match. That's just out of habit and out of experience. I know that origin is what it kind of expects, and that's the start of a ray or the origin of the ray. So I name my variables to match. It's not something magic. It doesn't have to match, but it does because of habit mostly. So our first variable is the origin. The next variable, I hit comma and space, is the direction. And the direction that we want to go in is downward. To get down, we'll do vector2 dot down. Next, we need another parameter. So right now, it would allow me to add a semicolon and be done, but that's not what I want. That would give me an array that goes from my origin down infinitely forever. I want to add another comma here after the down. I want to add a maximum distance, and I want to go that 0.1 meters, or that 1/10 of a meter, the same variable that I've got right here. So 0.1f, or the same value. It's not really a variable, it's more of a constant. And the last thing that I want to do is check for the ground. And to do that, it's a little bit more complicated, so we'll wait until the next section. We'll get into the layers, but there actually is another layer mask here that we'll use shortly after. For now, though, we're just going to go with these 3 parameters, and then we'll go to the next line. And we'll say if, and then open parentheses, hit dot collider, and then closing parentheses. So what this is going to tell us is if we hit an object and or we hit something and there's an object there. If that's true, then hit dot collider will just basically return back true. It's actually going to give us back the collider, the instance of it, but this variable check, this if check, is going to be true if that thing exists, and if there was no collider, if we didn't hit anything with our laser beam, then it's going to return back false. So if we did hit something with it, then we want to set a variable to true, and we're going to set a member variable, something that we can see in the inspector and that we can use later on. Let's call that is grounded with a capital I. So we'll say is grounded equals true and a semicolon. Now we're going to hit enter. Don't worry about that error. We're going to address it in just a moment. Next, we're going to write the word else, E-L-S-E, which is also going to be purple. And then we'll hit enter one more time. We'll say is grounded equals false. Now, if your editor added some braces around things like this, don't worry, you can just delete those. You can leave them in there, but if they're the wrong way, then you don't want to have them there. So you can just hit Shift Delete and Shift Delete, get rid of those braces. Now, what are we going to do about this is grounded, and what does this else statement mean? Well, the else statement means that if collider is true, well, we'll set is grounded to true, but if collider is not true, so otherwise, or if else, not if else, but else, then is grounded will be set to false. So we're essentially setting grounded to true if we've touched something with our laser, and setting it to false if we haven't. But is grounded doesn't exist, so we need to create it. And to create it, I'll select it, hit Alt Enter, and we can generate a field, a property, a local, or a parameter. The one that I want to choose is a field. We're going to generate a field right up at the top, and that's going to give us a private bool named is grounded, and I'm going to change this private and make it public. We'll save and then look for errors. Let's go take a look at the entire script. This is all of the script. This should show us everything. Let's jump back into Unity, and now if we go select our player, we should see that is grounded field. Remember that I said that public fields and serialized fields both show up in the inspector, but public ones you want to use a little bit differently. Let's go check it out. We should see our public field showing up any second now, as soon as it finishes compiling. Our is grounded. Now let's press play. There we go, and I fall down. When I'm on the ground, the is grounded is checked, which means true, and when I jump in the air, it's not checked. As soon as I hit the ground, it's true and checked. As soon as I jump off the ground, it's not checked. Pretty cool, right? Now we can tell whether or not our player is grounded. The last thing that we need to do for our jump modification then is go down to the jump code, where we check to see if they pressed the button down, and we just need to check if they're grounded as well. So if they're not grounded, then we can't allow them to continue to fly up or to start a jump. Not to fly up. We don't want to stop them from continuing a jump, just from starting a jump. So here on line 36, if they pressed fire 1 and, so remember we got to add the double ampersand in between the two parentheses, and is grounded. So what that's going to say is if they're grounded on the ground and they've pressed the button, they can start the jump. Otherwise, this will never return true. The and means that both statements have to be true. Let's go jump back into Unity. I'm going to press play, and now I should only be able to jump if I'm on the ground. Jump. Oh, look at that. I can only jump when I'm on the ground. I can hold a jump, but I can't, or I can kind of continue a jump. So watch, if I'm already jumping, I can continue it, but I can't start a new jump. So I can't get to the top and keep jumping. That's looking pretty good. We've got our raycast working. We've got our grounding working. I think it's time for us to go into plastic and commit our changes. So here we've added a grounding check for our jump to the player. So added grounding, or let's say added is grounded to the player and made the jump check for grounding state. And then we'll check in.